All right, welcome you guys. So in this section, we're going to be solving linear equations. Okay. So we'll progressively work our way into tougher ones, like ones with decimals, ones with fractions. Okay. This is here in your notes. It's also here on this front page if you want to reference it. I'm probably just going to dive in and do them. But let's say you're doing a problem on your homework and you're not sure like how to proceed, and think to maybe come back to this page to help you. Okay. All right, so let's go ahead and start. All right, so it says solve the following linear equations. Okay. So the first thing that we want to do is we want to distribute the number that is directly in front of the parentheses. And if you go back and look at the last page, the step one, distributing is the first thing we want to do. So distributing is multiplying. So we're going to take that positive 4 and we're going to multiply it. So I'm just going to bring x down. And 4 times x is 4x. And then you have to think about the signs. Now, I have students who go for the number right away. Don't do that. That's why they mess up on signs a lot. Give signs the priority and the emphasis that they deserve. I mean, if you're going to miss something in algebra, odds are it's a sign. So we know they're tough. So let's focus on them and give them our attention. Okay. So this is a positive 4 multiplying by a negative 5. A positive times a negative is a negative. And then go ahead and do the 4 times 5, which we know to be 20. All right. So we got 4 times x for 4x. And then we've got a positive times a negative, so it's still negative. And 4 times 2 is 8. So piece it out. Don't think about the numbers and the signs all at once. Take care of the signs, then take care of the numbers. All right, so we're going to go ahead and combine like terms. That's the next step. So we're going to combine two x's that we see on the left-hand side of the equal sign. Remember, there's always a 1 in front of stuff, you guys. So there's really a 1 here. So 1x plus 4x is what's going to give us 5x. All right. Now, there's lots of different ways you could proceed from here, but always deal with the variables first is what I would say. So if you have variables on both sides of the equation, like we do, deal with the variables first, okay? So move the variables before the constants, okay? A lot of students want to move just the numbers, but then they end up doing extra work because they'll move a number over and then sometimes they have to move it back, okay? All right. So, and the way that I like to do it, now you can do it any way you want. There's 2 schools of thought, and I think they're both great, okay? What I do is I always move the smallest of the 2, and let me talk about why I do that. So I'm going to move the smallest of the 2 because then I'll always have positives. Let's say I don't move the smallest. 5 is bigger than 4. Let's say I move the 5. If I move the 5x, what I've done for myself is I've created a negative now. 4 minus 5 is going to get me a negative. And like I just said a second ago, the main issue most people have in algebra is the signs. So if I instead choose to always move the smaller of the 2, then that will leave me with a positive number. 5 minus 4 is just 1. So this is 1x over here. So I always deal with the variables first, and I always move the smaller of the 2 variables. Now, some teachers teach their students, which this is great too, this is the other school of thought, to always get the variable on the left, which in this case, it just so happened to be the same thing, the variables on the left. But let's say it had been like the 4 over here, and then the 5 over here. They would still say to move the 5 because they want the variable to always be on the left. So they would have gotten a negative in this case, okay? Whatever you're comfortable with, whichever one makes the most sense to you, do that, okay? I honestly don't care as long as you're getting it right. All right, so but deal with the variables first, okay? All right, so now to get the x by itself, it has a minus 20. So we are going to do plus 20 to make it cancel out. Negative 20 plus 20 is 0, so we cross it off. So we have x equals, and negative 8 plus 20 is 12. So this is going to be the answer. And I can't remember how your textbook writes it. Sometimes we write it, oops, in curly brackets like that. Oh boy, I'm really bad at the one on the right. There we go. So either one of these answers is correct, you guys. Okay. Let me think if there's anything else I wanted to say on that. You said move the smallest. Maybe I should actually type that in here, just so like if you're going to continue to work with me, you'll know, what the plan of attack is. So if variables on both sides of equation, move the smallest variable to keep the terms positive, to keep the coefficient positive. There we go. Okay. And I will just draw a little arrow, you guys, to this step right here. Okay. All right. Number 2. So same thing. We're going to work on that distributing first. Okay. Now I'm going to bring down my 2x, and it is a -3, not just the 3. I think a lot of students miss that. It's a -3 that's going to distribute into those parentheses. So a negative times a positive is negative. 3 times 2 is 6, and there's an x, so 6x. And then it's another negative times a positive, so it's going to be negative, and 3 times 2 is 6. All right, we'll do the same thing on the right-hand side. We got a 1. We're going to take this -5 and multiply it by 4x. So a negative times a positive is negative. 5 times 4x, that's going to be 20x. And now let's go ahead and distribute the -5 to the 3. So a negative times a positive is a negative, and 5 times 3 is 15. All right. So then we're at the combine like terms on the same side of the equal sign. So we're going to combine 2x minus 6x. So that's going to give us -4x. And I'm going to bring the -20x first, and then we'll combine the like terms that are constants. So 1 minus 15 is going to be -14. All right. Now we know that we said there are variables on both sides, so we're going to move the smallest. So I'm just going to be really repetitive because I don't know about you guys, that's what my brain needs. It needs that repetition. So since variables on both sides, move the smallest. So in our case, the -20x. -20 is smaller than -4. All right, so we're going to go ahead and it's -20, so we'll put plus 20x. And whatever you do to one side of the equation, you got to do it to the other side to keep it balanced. All right, so -4 plus 20 is going to be 16. And then we have to try to get x by itself. That means the 16 and the -6 have got to go. Always save the number in front of x for last. So I'm not going to do the 16. Okay, I'm going to do plus 6. So let me say that again. Whatever's in front of the variable, save that for last, okay? All right, so we got 16x equals -8. All right, here's our last move. The number in front of the variable is always last. Now, you put this in to my math lab. It will mark it wrong, probably. I have to go check the settings, but I'm pretty sure it will. Because we need to get into the habit of always reducing everything, every fraction, okay? So I noticed that 8 divides into both of these. So I'm going to divide them both by 8, and then that should be reduced. So -8, oops. Oh, I'm sorry, what am I doing? So 8 divided by 8 is 1, and 16 divided by 8 is 2. So this is going to be 1/2 negative. Now let me go over to the Casio emulator to show you what that looks like. So if we have -8, I guess I'll do this because this is what most students would do. 8, down arrow, 16, right? Let's see what happens when we hit equals. It automatically reduces it for you. So if you have the Casio 300 FX, right, the one that I've been telling you guys to get, that's the one that will just so user-friendly. Remember this button here, if you want to go decimals with it, you just click that, decimal. Click it again, you're back to fractions. So S to D button is super, Super great button. You're going to love it. All right, we'll tell you this for my tests that we take in person, the paper tests, I usually go fractions with it. Most mathematicians like the fractions better than the decimals. Okay, so we've learned a lot here. We cannot leave fractions that are not simplified or not reduced. Got to make sure we go in there and reduce them. All right, example C. So this is terrible looking, right? If you're somebody who struggles with decimals right now, you're just like gulp, right? But I'm actually the first thing I'm gonna do is get rid of the decimals. So you have to make sure that you figure out how many times you'll have to move the decimal in order to get rid of it, okay? So here we can see that we need to move the decimal one time, okay? We need to move the decimal, once to get rid of it. To get rid of it. Okay, so what I mean by that is, I'll give you a couple, I'll show you visually what that looks like. If I move it once here, it'll become a 6. If I move it once here, it'll become a 13. And if I move it once here, it'll become a 2. So once got rid of it on all of them. I'm going to give you a second example to show you what would happen. And oh, by the way, look at this, you guys. Is that not great? It went from gulp to, oh, they're whole numbers, right? So this is awesome. Now, if you were to have, let's say, the same exact one, except for it was like this. Well, in that case, I can't just move it once because sure, I'd get rid of it here, but look at here, it'd just be 1.3. So we're going to have to move it twice to make the decimal go away in this one, which means you've got to move it twice in all of them. So this would become a 60x, a 13. And if I move it twice here, this one would become a 20. So basically, you're going to have to find the largest number of times that you'll have to move it to get rid of it and do that to all of them. You just have to be consistent on all of them. Okay. Now, what's technically happening when we're moving the decimal, okay, is we're multiplying by, like in this first example over here, we multiplied by 10 because we only moved it once. Over here, we technically multiplied by 100 because 100 has 2 zeros. So you would move the decimal twice, right? Over here, it was 10 with 1 0. So you move the decimal once, okay? Now, something that I want to point out is I did not do it to the 5 and the 8 here. And that's because if I multiplied this guy by 10, which I did, I moved its decimal once. So I multiplied it by 10. When this distributes now over here, right? The 10 that's kind of inside of this is gonna get distributed to the 5 and the 8 anyways. So you don't want to double do it. If you move it here on the 5 and you move it here on the 8 and you also move it on the 2, well, then when you distribute the 2, you've double moved it, okay? Because of the 10 that's inside of this 2 right here, right? We multiply this guy by 10, there's a 10 over here that's going to get distributed. So don't double do it. So in other words, we're not going to do it to the stuff in the parentheses if I could just sum it up, okay? So let me just put a little underline here and just make a little note. Don't move decimal here. We discussed why we don't want to double do it, okay? All right, so hopefully this kind of clarifies, if one of them needs it twice, then they all have to be twice. In this case, they were all once. We got lucky. Don't hit the parentheses because when you distribute, the parentheses will get it. All right, let's continue on with this way better, right? Way better equation. All right, so we've got 6x minus 13 equals, and we're going to distribute here. 2 times 5 is 10. And 2 times -8 is -16. Variables on both sides. So we've got to move the smallest, right? Oops. So the smallest here would be the 6x. So we're going to move the 6x. So we'll take away 6. That way we have 6 minus 6 for 0. And that leaves us with a negative 13. All right, now, remember, we said we're trying to get x by itself. So I have to move these two things. If I can move those two things, x will be by itself. Remember, whatever's in front of the variable is always last. So we're going to be moving that 16. So if it's a minus 16, we're always doing opposites, and we're going to do a plus 16. So we create a 0. Negative 13 plus 16 is 3. 4 is multiplying by x, so the opposite of multiplying is dividing. And this is good enough for me. These cancel. X equals 3/4. I told you fractions are fine, but you could also put x equals 0.75, and both of these would be okay. All right. So we learned on this example, and we'll use this throughout the class, that if your equation has decimals in it, you don't have to work with decimals if you don't want to. Now, if you're somebody who's fine with it, cool, just proceed. But if you don't like decimals, you can always get rid of them. The key thing is that it's an equation. Never do it on an expression. So in other words, there has to be an equal sign for you to be able to do it. Okay, so here's another case of you don't have to work with it like this if you don't want to. Okay, most people don't like fractions. So let's just talk about, how to get rid of the fractions, and so that you never have to work with them again, as long as it's an equation. To get rid of fractions in an equation, multiply the numerators of all terms by the LCD. It turns out you don't even have to use the LCD. If you're like struggling to find the least common denominator, that's fine. Just find a common denominator. Sometimes that could be hard. Okay, so as long as you can find any common denominator, it'll do it. But the LCD is the best one because it causes less reducing in the end. Okay, it keeps our numbers smaller. All right, so let's talk LCD. So I'm looking at all the denominators, and I'm trying to figure out what is a number that 3, 6, and 2 can all divide into. Not that divides into them, but that they divide into. Now, sure, like 8, 12 would work. 18 would work. These are numbers that they all go into. But the least would be 6. Let's think about it. Okay. Does 3 go into 6? Yes, 2 times. Does 6 go into 6? Yeah, 1 time. And does 2 go into 6? Yes, 3 times. So we have found the perfect number. Now remember, we're multiplying all of the numerators by 6. All of them, even this negative 3 here. And this is kind of messy, you guys. I haven't really found a good way to make this pretty, but usually after a few examples, my students get it. I'm going to make this a little bigger. Oops. Push the hand first, just a little bigger. There we go. Okay. All right, so now we're not actually going to multiply. We are going to, cancel first. So 3 goes into 6 2 times. So we're going to do 2 times 2 here. So it looks like we're going to get 4x, you guys. On the next one, this 6 and this 6 will cancel, so don't actually multiply. So all that's left is minus 5x. And then 6 times negative 3 is negative 18. Then we got our equal sign. So then let's go over here. 2 goes into 6 3 times. So we have 3 times 1, which gets us 3. And then 5 times 6, which gets us 30. So in all the fraction ones, you're actually going to divide. And then anyone that's not a fraction, you're going to multiply. And we'll do more of these. If you're like, what just happened? We'll do more. All right, so right there, 4 minus 5 would get us negative 1. This is us combining like terms. All right, variables on both sides. So we got to move the smallest, right? The repetition, you guys, is just going to help you when it comes test time. You'll just hear my voice in your mind saying that again. All right, variables on both sides. So move the smallest, which would be the negative x in our case. Okay. So let's go ahead and do plus x. If it's a minus x, then we're going to do a plus x to both sides. So we get negative 18. And remember, there's a 1 in front of that x. So 3x plus 1x would get us 4x. And remember, the number in front of the variables always lasts. So we know we have to get rid of these two. Well, we're doing that for last. So that means we got to do the 30 first. So if it's a minus 30, then we're going to do a plus 30. So negative 18 plus 30 is 12. 4 times x, so we got to divide to get rid of it. The opposite of multiplying is dividing. 12 divided by 4 is 3. 4 divided by 4 is 1, which we're not going to write. So we get that x equals 3. Cool. So the big thing was, look at this technique. This first equation was terrible. And in one line, look how nice this is. All whole numbers. So this LCD trick just makes your life so much easier. And we're going to use it often in the class, you guys. Okay. Any chance we get. Okay. All right. Now, when you're solving equations, 9 times out of 10, if not more, 99 times out of 100, I don't know, you get an answer like we did. We had like 3, x equals 3, x equals 3/4, but you don't always get that situation. Okay, so let's talk about other situations. So if you do these last 4 that we've done, they've all been conditional because we got an answer like x equals 3. Okay, I'm writing down what the solutions look like. Okay, let me put that here. Solution might look like that. All right, and this is called conditional because what you're saying is this equation right here will be true under the condition that x is 3. If you plug in any other value for x, then this equation will not work. It won't, the left side will not equal the right side. But if you plug in 3, it'll be true under that condition. Now, the other types that can happen is an identity. So let's just talk about an identity really fast. Let's say that you're solving an equation and you get to this point, something like this. You can see that the left side equals the right side. This is an identity. And what that means is it doesn't matter what number somebody picks, it's always going to work. Somebody could go and plug in, I don't know, they could be like, I'm going to substitute in a 4. Guess what? It's going to work. This should be really evident as I go through here, right? 8 minus 3, 8 minus 3, 5 equals 5. It worked. Somebody else could say, I'm going to pick -1. And of course, -1 is going to work. We get what? -2 take away 3, -2 take away 3, -5 equals -5. So any number will work is the takeaway, right? Any number will work. So how do we write that? So the solution, how we could write that is we could say all real numbers. Okay. Sometimes I've seen this just capital R that you'll just click on if you're on like Connect Math or My Math Lab. Maybe it'll just have this symbol, this bolded R. Okay, or if they say give the solution set in interval notation, it could even be from -infinity all the way to infinity. All of these are saying the same thing. They're saying, doesn't matter, plug in whatever you want, the left side will equal the right side, okay? All right, then the exact opposite of that, so the exact opposite of an identity is going to be a contradiction. So the way that you can spot, oh, by the way, I forgot to tell you. So on this 2x minus 3 equals 2x minus 3, right? If sometimes students can't spot it because they're just in the zone of like doing algebra, that's fine. If you went to continue to solve this, right? Variables first. We said if variables are on both sides, then variables first. If I take away 2x from both sides, I end up getting -3 equals -3. That is a true statement. -3 does equal -3. That's how you can tell that you're going to get all real numbers. Now over here, if we look at a contradiction, it might be something like 2x minus 3 equals 2x plus 4, okay? This is a contradiction. If we went, I mean, think about it. If you plug a number in here, you're going to get the same thing if you plug a number in here, okay? But over here, I'm taking away 3, and over here, I'm adding 4. And there's no way they could equal each other, right? Like, let's say I plug a 4 in. Okay, 4, take away 3. There's no way that could be 4 plus 4. I'm sorry, I said plug in a 4, huh? 2 times 4 is 8, just kidding. So 8 take away 3 could never equal 8 plus 4, right? So anyhow, how you would recognize this is you would go in and you would take away the 2x like we said before. But this time you would get -3 equals 4. The variables fell off the paper. There's no more variables. This is not a true statement. This is false. So instead of any number working, it's quite the opposite. It's no number will work, right? No number will work. So how do we write that no number will work? So in the case of a contradiction, the solution is going to be no solution. Maybe you'll pick that from a drop-down menu if you're on, My Math Lab or whatever. Or maybe you'll pick the empty brackets with nothing inside of them. Okay. So those are the way that we denote that the solution is going to be a no solution. Okay. No matter what you pick to plug in, these will never equal each other. Okay, so let's go in and do a couple. Or maybe now anything's game. It could be conditional, identity, or contradiction. Okay, so solve the following. Now, these are brutal. We just want to make sure you're super good. So I'm going to start with the innermost parentheses. These are parentheses too, you guys, but it's like the second set of parentheses. Like that people don't like to see like this type of a deal because it's kind of hard on the eyes. So once a second set of parentheses has gotten in there, they start using brackets. So it's a little bit easier on the eyes, but they're parentheses. Just think of them as parentheses. They're grouping symbols, right? All right. So we're going to go to the inside and we're going to clean this up. So I'm still going to bring down my 2 bracket. Okay. But we're just going to clean up. And the only way I can see to clean up right now is to distribute this 2 in. So we've got 4 plus 2 times 5, which is 10. And a positive times a negative is a negative, and 2 times x is 2x. Now the parentheses are gone after we distribute, just like over here on the right-hand side. Once we distribute, the parentheses are going to go away, right? 4 times 7 is 28, and 4 times 2x is 8x. Now we're still going to work on cleaning up the inside here. I'm not going to do anything else, but I'm just going to clean up the inside. So we can see that 4 plus 10 is going to get us 14. And then -2x and -2x are going to make -4x. All right, now I'm ready to distribute in. Remember, those are just parentheses. I'm ready to distribute in the 2. So 2 times 14 is 28. 2 times 4x is 8x. And probably at this stage, you might be able to spot that it's an identity. The left side equals the right side. So hopefully right here, you can see that it's an identity. But if not, then you would just proceed variables on both sides. Let's get rid of the variables. If we add 8, the variables fall off the paper, and that is a dead giveaway that it's either a identity or a contradiction. Since this is a true statement that 28 equals 28, then this is going to be an identity. Now remember, don't write identity. That's not the answer. They want the solutions. When you say identity, that's the type of equation that it is. Okay, so what's the solution? Well, all real numbers, right? All real numbers, or the bolded R, or negative infinity to infinity. This all depends on the textbook you're working with, you know, what you got on your online homework program, whatever. Now, I could proceed. Make sure you understand the difference, okay? So I always had students that missed this when I had a paper test. I would say, solve this, and they would say identity. It's like, oh, that's not solving it. If I said to you, what type of an equation is it? That's when the answer would be identity. What type of equation? Well, the answer is that would be an identity. Okay. All right. Now this next one is actually the same thing. It should look familiar. There's one little change. I want to say it's right here that this becomes a minus 2x, but let me go see. Yes, this is going to become a minus 2x. I'll go through the math again because we could definitely use some repetition. Okay. So let's see here. 2 bracket 4 plus 2 times 5 is 10. 2 times negative 1x is negative 2x. 4 times 7 is 28. 4 times 2x is 8x. We're going to combine like terms. 4 plus 10 is 14. Negative 2 and negative 2 are going to make negative 4. Now, if we distribute the 2 in, 2 times 14 is 28. 2 times 4 is negative 8x. Now let's stare at this. This is not an identity. They're not exactly the same. So we have variables on both sides. So we're going to move the smaller of the two. Well, the negative 8x is smaller. So we're going to do a plus 8x and a plus 8x to get 28 equals, these make 0. 8x plus 8x is 16x. Now, get rid of the 16 last, right? That save the number in front of the variable for last. So we're going to move the 28. We got 0 equals, that's gone. Now we cross it off here. I mean, you could put a 0, but it's just going to give you extra work. But you can't put nothing. Sorry, I got a lot of stray marks here. You can't have nothing over here. Does that make sense? It can't just be like equals and there's nothing there. So in that case, we write the 0. Okay. And then we got 16x. When this always weirds some students out, we're going to divide by 16. Well, 0 divided by 16 is 0. Remember, you guys, if the 0 is on the bottom, it's undefined. If the 0 is on the top, it's just 0. Now, if I said to you, so that's the solution. I said, what type of equation is it? Maybe you remember that it's conditional. It's true under the condition that x equals 0. All right, solve the following linear equations and decide what type of equation it is. So same directions. All right, so let's go ahead and do a bunch of distributing, huh? All right, negative 3 times x. A negative times a negative equals a positive. 3 times 2 is 6. 4 times 2x is going to be 8x. A positive times a positive is, of course, positive your whole life. A negative times a positive is negative. A negative times a negative is positive. All right, so now combining like terms. So we're going to combine the x's. Negative 3x plus 8x is 5x. 6 and 20 make 26. We're going to combine our x's. So 10x minus 5x is 5x. All right. So variables on both sides. We can't really move the smallest because there is no smallest, but we'll move the 5x. And we can tell right here at this stage, something's funky, huh? Because the variables just fell off the paper. So we got 26 equals 23. This is a false statement. 26 doesn't equal 23. So this is going to be no solution. Let me put the or empty brackets. Boy, I'm really bad at those, but you guys get the gist. Okay. Now it says what type of equation is it? So what type of equation? So this would be the other C word, not a conditional. This would be a contradiction. Okay. All right. And you might spot the contradiction sooner, like at this stage where you're like, well, there's no way 5x adding 26 to it could be the same as 5x adding 23 to it. So done, no solution, right? Wherever you can spot it. I'm not going to require you to show those extra steps. You can spot it. Great. So what we learned from that is not all equations are just going to have x equals blah. Sometimes we get no solution. Sometimes we get infinitely many, right? All right, or all real numbers. Okay, the zeros of a function. I want to say this is our last example. Let me just go in and see. It is. Okay. All right, so the zero of a function, let's just talk about what that is, okay? So it says right here, an input C of a function f is called a zero of the function if the output for the function is 0 when the input is C. So it's basically saying it right here. If you plug C into the function and you get 0 out, that's when we call it a 0. So the main thing that I want you to take away from this, it's a 0 if the y value is 0. Reason why I'm making a big deal out of that is you'll just have some equation, right? Oh, sorry, I forget that it does that. All right, so if you have like f of x equals 9x plus 7, and for me, if somebody's like, find the 0, I'd be going, oh no, dang it. Where do I put the 0? Do I put the 0 in for the x or do I put the 0 in for the y? You're going to put it in for the y, you guys, okay? So let's keep reading because this kind of sums that up. It says, there are many names for the zeros of a function. They are also called roots, solutions, and x-intercepts. Since the y value is 0, a 0 is where a graph crosses the x-axis. So imagine that you have, make this black, you have your x and y axis, okay? The spots where the graph crosses, these are called x-intercepts, just like it says up here, right? And if you think about it, you know, let's say that this is like 2, and let's say that this is 5, then these would be the ordered pairs, 2, 0, and 5, 0. Notice the y value is 0 because we haven't moved up or down. Y is moving up or down, okay? So visually what we're looking for is where does it cross the x-axis? How do we find it? We let the y value be 0. Find the zeros of the function, then sketch a graph to verify. All right, so that means we're going to substitute a 0 in for the y. All right, so we just got to solve this. Remember, save the number in front of the variable for last. So that 5 is going to be last. So let's do the plus 9 first, you guys. All right, 0 plus 9 is 9. Okay, we'll divide by 5. So we get x equals 9/5. Okay. Now, by the way, there's lots of ways to write that. 1 and 1/4, right? We said if you just put 9/5 into 9/5 in, then you hit equals and then hit S to D, you could get the decimal for it. Now, just stay fractions, you guys. Honestly, improper fractions are completely fine, okay? But it's nice to know 1.8 because then that tells me it's going to be over 1 point. So somewhere around here, okay? That's going to be where 1.8 is, I guess. Okay, so we want to sketch the graph to verify. All right, so let's go in here and remind ourselves how the heck we graph lines. So our y-intercept is always the b in the y equals mx plus b. So the -9. So 0, -9 is where we would cross the y-axis. Then the slope is 5, or 5/1, because our slope always has to be a fraction. So we have to figure out if we're going up or down, if we're going left or right. It's positive, so we'll go up. The 1 is positive, so we'll go right. So we're going to go up 5, right 1, up 5, right 1. So here we go, up 1, 2, 3, 4, 5, right 1. Let's do it again. 1, 2, 3, 4, 5, right 1. And now it looks like we did a good job, because if I were to draw a line right now, right, it looks like it would pass through that point. Sorry, you guys, I don't know what happened there. There we go. Bam. It does go through that 0. And we just kind of estimated, you guys, but that looks great. Okay, so it does check out. Just put a little check here. Okay, awesome. So on your homework, when it says find the zeros, make sure, in this case, it was only a 0. Sorry, this should have been in parentheses. Make sure that you're plugging the 0 in for the y. All right, you guys, that does it. Thanks for joining me. There's going to be a part 2, but it's all word problems. I wanted to make the word problems their own section to give it the importance that they deserve and to make sure I don't skimp on it. People tend to be bad at word problems because they skip them, or they don't see enough examples in their classes, because, you know, teachers are always in a hurry trying to finish every section and stuff. So I just wanted to make sure I didn't do that to you, but that I gave you, you know, a plethora, that we did enough to where you start to feel comfortable and kind of see them as algorithmic. So that's what's coming next in 1.5 part 2 is linear word problems. All right, guys, thanks for joining me. Take care.